The engineering in this, a modern disposable diaper, stuns me. It's a triumph of polymer science. A super absorbent polymer soaks up urine, but that's only part of the story. Its brilliant engineering lies in the creation of interlinked mechanisms that operate on different timescales. They whisk urine from a baby's skin and distribute it to the diaper's superabsorbent, which traps the urine. Let's work our way from the outside in. The outermost layer is a thin, soft covering, almost impossible to remove in one piece. It's there for the parent's comfort. It feels like cloth, but it's made from plastic. The next layer is a barrier sheet. Typically, it's polyethylene, the same stuff used in plastic grocery bags. This plastic barrier is there to contain feces. Along the diaper's edges are elasticized leg cuffs, which is noted in one of the many patents help contain explosive, liquefied bowel movements. So containing solids is simple, but where the diaper excels, where its engineering astonishes me, is its handling of urine. To sweep it away from a baby's skin and to keep it away is the task of the diaper's 3 inner layers. The top sheet rests on the child's skin. Bonded to it is the surge layer, called in the industry the acquisition distribution layer, and then the absorbent core. A cross-section of the diaper shows the relative thickness of these 3 inner layers. The top sheet is very thin, the surge layer a little thicker, and the absorbent core the thickest. Each has a different function. The top sheet's behavior surprises me. Most liquid goes right through the mesh, but when I gently place a drop of liquid on the top sheet, it beads up. I've been able to get it to stay there 6 hours. I'd expect the top sheet to be highly absorbent, to soak up water, but the fibers in the top sheet, the part touching the child's skin, repel water. Well, at first counterintuitive, this action is central to keeping a child dry. Urine passes through the holes of the top sheet, which is made from polypropylene, because it strikes the top sheet at over 6 miles per hour. Once through the top sheet, its water repellence helps prevent the stagnant pool of evacuated urine from flowing back onto the child's skin. As I insult the diaper, the liquid passes through the top sheet and enters the surge layer, which swells rapidly. Watch as that layer distributes this localized insult throughout the length of the diaper. As the surge layer empties, the absorbent core swells. To whisk the liquid from the top sheet to the absorbent core, the surge layer uses capillary action. You can see that with this device. As I fill it, the blue liquid climbs up each of the capillary tubes. Most absorbent material uses this action. For example, the threads of a washcloth form channels throughout the fabric. By capillary action, liquid climbs into these channels. Note, it isn't the fibers that absorb the liquid, but the spaces or channels between the fibers. In an absorptive material, the size of the channels determine how much liquid is moved and how fast. Notice here that the smallest diameter tube moves liquid farther than the largest diameter tube, but of course the smaller tube moves a smaller volume of liquid. The channels in the surge layer are arranged like these 4 tubes. Near the baby skin, the surge layer has large channels. This moves a lot of liquid quickly, fast uptake, and then further from the skin, a more dense network of fibers which creates smaller diameter channels. Not only does this arrangement of channels whisk the urine away, it also works like a one-way valve to prevent urine from flowing back toward the baby's skin. You would think that something this absorbent would be woven like cloth, but to weave a fabric with varying channel size would be extraordinarily difficult and expensive. Instead, to construct the surge layer, diaper companies use non-wovens. In a woven fabric, the strands are carefully interlaced, but in a non-woven, polymer fibers are suspended in air and then deposited on a moving belt where the warmed fibers adhere to each other. It's a lot like making cotton candy. There, the fibers mat together to make something that resembles cloth, but clearly isn't woven. As the urine leaves the surge layer, it enters the absorbent core, which stores the urine until a diaper is disposed. It must hold urine for up to 9 hours or so as the child sleeps. A number 4 size diaper can hold about 400 milliliters of urine. The urine is trapped in a super absorbent polymer. Here I have 5 or 6 grams of that polymer. I'll mix it with 160 or so grams of water. As the polymer absorbs the water, it swells and turns into a gel. Now these superabsorbents are truly amazing things. This bag contains hundreds of small spheres, each 4 millimeters in diameter, made of a superabsorbent polymer similar to what's in diapers. Watch what happens as I set a single sphere in a watch glass and cover it with colored water. Over 4 hours, it soaks up the water and grows. The superabsorbent contains long polymer chains, long chains of carbon molecules that create channels like the fibers in a washcloth. These channels between the polymer chains absorb the water by capillary action. The water also sticks to the superabsorbent. The chains are designed to chemically attract water. It forms this sphere because the polymer chains are attached to each other. It's called cross-linking. As the polymer attracts water here, the water, so to speak, becomes caught in a net of polymer. The superabsorbent turns into a gel and traps the water, or urine, in the case of a diaper. In fact, I can roll the sphere around in my hand and it still holds water, even though it's some 99% water and 1% polymer. Superabsorbent is so effective that when it forms a gel with the urine, it can block the flow of urine to unused parts of the absorbent core. So in many diaper brands, it's mixed throughout with 15% or so cotton, which provides channels for water to reach the unused superabsorbent. The details I've shared with you about how a diaper works astonish me, but equally stunning is the speed at which this precision object is made. Diaper lines produce around 1,000 diapers a minute. You'll likely never see one in person. The way each manufacturer designs their apparatus to move a flappy object like a diaper at many miles per hour is a tightly held trade secret. I'm Bill Hammack, the Engineer Guy.